Hi guys! Today I will be showing you how to make a controllable fracture. I will be introducing different techniques in cell fracture, particle system, and geonodes. It's a mix of all, and the result is marvelous. This technique is used a lot in different scenarios. You will thank me for it later. So let's start our tutorial. Now I am modeling a concrete bench to use it as an example. If you don't want to watch the modeling part, skip ahead to 147. Here I'm not going to explain how I modeled the bench and how I set the scene. If you want a tutorial for modeling, I will gladly do it. I used a scene from the movie Hancock as a reference. Don't mind the guy typing under my nose. Doesn't he look so ridiculous? But what can we do? He wants to be in the video. Here I will apply a particle system to the bench, open source, and go to emit from, switch faces to volume. Next go to object, quick effects, cell fracture. Change the value of source limit to 0. And make a collection. Name it whatever you like. Change the margin to 0. And press OK. Hide the original bench, and don't forget to name it. Shift A, add a cube, move it up a little. Control A, apply scale. Go to geometry nodes, click on new. Now Shift A and add a collection info. Choose your collection. Press N, go to group, add an input, and name it whatever. I named it chunks. Change its type to collection. Duplicate your input group and connect it to the chunk socket. Switch from original to relative. Check separate children. Now add a geometry proximity, a vector math. Switch it to subtract. Connect geometry to geometry and position to vector. Add a position, connect it to the subtract. Add a translate instances between the collection and the output. Connect the vector subtract to the translation. Go back to the geometry proximity. Add a math divide. Don't clamp. Connect the first value to distance. Duplicate the math. Change it to subtract connect value to second value. Keep clamp on. Add a multiply vector math between the subtract and the translate instances. Now if you go to the divide and play with the value, you should have something like that. If not, go back and check the steps exactly as I showed previously and check for mistakes. Duplicate another math. Change it to power and change exponent to 2. Duplicate a fourth math and make it a multiply. Now, select your cube, the one we made at the beginning, and move it around. If you can't see the cube, just select the pivot point, press G, then X, Y, or Z to see the effect. I will fix this later. Now we will add a new output to control the fracture effect from the modifier tab. We will name it radius. Now drag the group input and connect the radius socket to the divide value for easy control. Change the min to 0.001. We don't want it to be completely zero. Now go to the Modifier tab and you have your own simple controller. You can play with the values till your heart content. Now, we will add a couple of other controllers. Add a new input, name it Fallout. Connect the power exponent to the Fallout socket, and so on. You get the drill. Control G and group the divide, subtract, and the power math together as one group. Tab for getting in and out of a group node. Name the group. Make one more for the power, and that's it. Next, we want to add rotation to the chunks, so go between the collection info and translate instances, add a rotate instance. Add an align rotation to vector, connect it to the rotation instance, and the vector subtract to vector. Connect the controller group to the align rotation factor. Duplicate math multiply and place it between the group and the rotation. Add a new input and call it rotation strength. Here I will add a join geometry to fix the visibility of the cube. Copy the input and connect the geometry to geometry. Now the cube is visible. You can move it around and see how cool it affects the fracture. Now we will add a new input and set its type to Boolean. Drag rotate instances, connect pivot point to the geometry proximity position, copy input and connect it to local space. Add a multiply vector math between the geometry proximity and the rotate instances. Now we want to set an on-off switch for the local space. Add a subtract math, set the first value to 1 for the on-off switch, and connect the local rotation input to it. Drag the vector math, multiply, connect the subtract value to it. Now we want to rotate the chunks individually, so we add a new rotate instances and a rotate Euler. Switch Euler to axis angle. Connect rotation to rotation. Add a random value. Set random value to vector. Connect value to axis. Set the min to 1. Connect the controller group to the rotate Euler angle. Add a new input to control the angle. Name it random rotate. Copy a new multiply math and connect the random rotate input to it. That's it, guys. I hope you liked the tutorial. It's a bit advanced, but you can do it. Thanks for watching.